Okay, why do I show this? Is some guy, I'd like to be that guy by the way, out on the glaciers, out on the ice fields in Greenland, trying to figure out what's going on. Well, what do those glaciers really hold the key to? Something this university is about to study real hard here. Sea level rise. Because we've got to understand what's happening to these glaciers and these ice fields to go figure out where we're going on sea level rise here. The whole dynamics of the glaciers, we have learned so much. I don't know if we've got any, I think we've got a few folks here who are studying that from what I got this afternoon. But it's just a fascinating intersection of the disciplines of glaciology, meteorology, oceanography, climatology, to go figure out how these dynamics are going to work. And what we're learning already is like these glaciers, as they get warmer water in the fjords, they used to be grounded. They'd come off the ice fields and they'd be grounded on the ocean bottom. And they'd stop. And think of, everybody's probably seen like those medieval cathedrals with those big flying buttresses that hold up the walls. It's kind of what these glaciers were doing in the fjords. They're holding up the ice. And that's cool, that's good. But what's happening now is warmer water. Now, a glaciologist's definition of warmer water is like 33 degrees. My definition of warm water is 80, but that's okay. That's what I like to swim in. But 33, 34, 35 degrees plus 2, plus 3 Celsius is getting into these fjords, and what it's doing is it's actually melting the bottom of the ice. So now rather than being grounded, it's just floating. So think of those cathedrals, and think of what happens when you start weakening and taking away those flying buttresses. What are those walls going to do? They're going to start spreading. And that's what we're seeing in the data. That's what we're seeing in the gray satellite data that measures basically the mass of West Antarctica and Greenland. So this is why, can I have the next slide please? This is why when the IPCC, the Intergovernmental Panel on Climate Change, came out back in 2007 and said, hey, we're kind of looking at 60 centimeters, 80 centimeters, maybe, but it was sort of that, hey, 2 feet, 2.5 feet, okay, it's, that's not great, but we can deal with it. So you got to deal with the thermal expansion, you got to, but you got to start thinking of this. If you read the footnotes in the IPCC report, they say, hey, we just don't know what's going on these ice fields. So, stay tuned for the next iteration. Well, now more and more people are studying it, and we do know at least a lot more. There's much more to learn. But I'm on record as saying that, I agree with folks like Dr. Richard Alley, who testified in front of the House Science and Technology Subcommittee a couple weeks ago. We're talking about 1 meter of sea level, global sea level rise by the year 2100. And if anything, I may be conservative in that estimate. It's just, what are these glaciers going to do? What are the dynamics? And that's a real cutting-edge science question. But that's one of the things we've got to look at. The next slide there. These are just some of the, I've tried to keep the words to a minimum in these slides, but these are just some of the things that, as you think through the questions of sea level rise, there's probably nothing earth-shattering here, but these are some of the things you got to think about. But the opportunities are also here. The opportunities of, if you've got to recapitalize your infrastructure, how do you make it more resilient? How do you make it better? If you got to do it anyways, and if you're going to have to spend that money at some point, how do you really build it for the 21st century, rather than just kind of doing what we've always done, or what I call paving the cowpaths? This gives us an opportunity. It also gives us an opportunity to form partnerships and relationships with organizations and groups that we may not have before. So what we're doing in the Navy is we're working with this outfit that, I'll be honest with you, I'd never heard of a year ago, called SERDP. It's a science, or what's the S? Say again? Strategic. I always forget these guys. Strategic Environmental Research and Development Panel. They work for the Office of Secretary of Defense, and they were actually called out in the Quadrennial Defense Review as the pros from Dover to go and take a look at sea level rise. They're a joint agency with the Environmental Protection Agency and the Department of Energy. I had the opportunity just a couple of days ago to speak at their annual meeting, and they have some really first-class researchers and academics and people, engineers who really study this. So there are certainly the opportunities here. So again, we're seeing today sea level coming up at about 3 to 3.5 millimeters per year. So what does that mean? That means that while this is absolutely a challenge, and it could be the challenge, as President Cook said, it is not something where you're going to wake up tomorrow morning and find 4 feet of water in your living room. But it is a challenge, and we have to address it. So what the Navy's doing is again, we're working again with our colleagues across the Department of Defense and other agencies to really understand the specifics of what's going on. We believe that report for Hampton Roads will be out in 2012. Our Task Force Climate Change sort of got locked in with CERDIP here very early on. And as a result, we were able to get Hampton Roads into the first tier of studies. I'm very happy to say that because it's so important to really understand what's going on in this area here. So we think by 2012 we'll have a pretty good report, and that will then help inform the specifics of what we need to do. Can I have the next slide, please? I don't know if you know this gentleman on your right, my left here, but with apologies to Tip O'Neill, sea level rise, like politics, is local. And so what you got to understand is, okay, it's hard enough to get our arms around these glaciers and what that's going to do to the global sea level rise. But then you also got to understand things like, okay, so what are the local currents going to do? Are they going to change? Because if they change, that actually changes your sea level as well. You need to have some idea of what storm surge frequency and intensity is going to be. And anybody who sells you a downscale regional model of a global climate model, be very, very careful of that. I can tell you after the meeting, if you're interested, I see stories from my days of doing hurricane and typhoon forecasting using that. Bottom line, didn't work so well. So I'll talk in a little bit later how we're going to attack that problem. And finally, you got to figure out if the land is going up or down. You know, because if you're going up faster than the sea's going up, it's like, hey, sell me that beachfront property. You know, if it's not working that way out, then I got to think about it. And you know, anybody who owns property here, I'm with you, because I don't know if you guys have heard of a little place called Waveland, Mississippi, down by Bay St. Louis, Mississippi. I was the one who bought the property right on the beach there, and well, it's sinking too, and the Gulf's coming up. And anyways, so I kind of understand where you're coming from. Do I have the next slide?